It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. Hey everybody, hopefully you guys are doing well. As usual, got a couple things I want to cover. Definitely want to get to your guys' questions in the chat, so do me a favor, and if you guys do have questions, throw them in caps lock, that way we can try to get to them. I've been trying, and it's difficult because oftentimes during these streams, there's over 1,000 chat messages, so I've been trying to go through the chat messages to see what things I missed. This week I'm a little bit behind, so I wasn't able to do it, but I was doing it last week too. But anyways, I'll try to go back if I miss anything, but don't hesitate to post everything again, guys. You're not going to piss me off. Just put it in caps lock and I'll tell you if I'm not going to answer it, okay? So just keep putting it in there. If I don't answer it, I'll, try to get my attention, all right? I really appreciate it. Thank you very much for that super chat there, Mr. Zach. I appreciate it. I covered I had two videos since the last time I did a stream. We did a bearing change on a Linux LGA package unit, the one with the two blower wheels and the big ass shaft. And then we also did a carrier package unit that I released last night, actually. Carrier package unit where I had another service tech out there changing he was doing a preventative maintenance. He found a burnt contactor. He changed it, but then it was short cycling. And anyways, I went out there to dig into that one. That was an interesting one. That's one of those things, that we want to make sure that we're being thorough and looking at the big picture. My little mantra that I'm always preaching to, try to figure out what's going on. Don't just assume that it's a contactor and move on. Obviously that one was pretty quick, so I got to see it pretty quick, but, going through the troubleshooting process to make sure that, we figure out what it is. I isolated each pressure control, and then even after I, kind of figured it was the high pressure control, I still hooked the high pressure control back up to get it to do the same thing again. And then once I was done installing the new pressure controls, ran the unit and continued to diagnose. So again, we don't just stop at the initial diagnosis. We look at everything. Now, in my opinion, this unit was probably running some higher than normal head pressures during the summer. It was probably going off on high pressure, and that's probably what damaged the high pressure control. More than likely, it was running the high head pressures because someone overcharged it because the unit has a plugged fixed orifice metering device. Okay, so it's things like that. You got to unravel everything. All right, we're there to solve the problem, not the symptom, right? So, just big picture. That's what I'm always preaching. And I'm not perfect. I make mistakes, but, I try to do my best to look at everything. All right. I want to address too with the Linux package unit where I had the blower wheel shaft, all that good stuff. There's certainly better ways to do that. And I even said something in the video, people are probably going to say, hey, do this, do that. There's always a better way to do it. Okay. Sometimes you have the tools that you have on you. But the one thing I will say, I did get 1 or 2 comments from people asking me, why didn't I save the shaft? Why did I change the blower wheels? Inevitably, time is money. That's what it comes down to. I could have spent an entire day. That job, changing everything that I did, I think I billed out 8.5 hours, I think. And that was 2 technicians, 4.25 hours each, I think is what it was, because we needed a second person to get the assembly out. I could have stayed there longer. I could have, gotten the blower assemblies off. But what happens when I went through all of that and one of the blower wheels was out of balance? Okay, because what can happen on high RPM units is the blower wheels can actually rebalance themselves. I've noticed this. Now, people may say this isn't true, but I've noticed this. If they get a lot of buildup on them, when you clean them, they'll be out of balance. And it's just because in my opinion, they run that way for so very long that after time, when you go in there and clean it, then you put it on, then it's out of balance, and then it's just a nightmare. Okay, we don't need a unit shaken off the roof. It's easier, in my opinion, and faster, in my opinion, just to go in there, cut everything apart, put new blower wheel, new shaft. Everything was cheap enough. Okay, I did the math to say, hey, you know what? How much is it going to cost to do this job if I didn't change all these parts? Because all I needed to change was 2 bearings, in all honesty. So, I guess theoretically I only needed to change 1 bearing, but both of them were in pretty bad shape, and I always change bearings as a set whenever possible. So, anyways, but I'm not upset. I know everybody, I ask for everybody's opinion when I do these videos. I appreciate your guys' comments, and I try to respond to them as much as possible, but definitely share with me your guys' methods of doing things. When you see that I do something different, say, hey, you know what? I do it like this. This is how I run into it. I'm always curious to hear how other people do, the same jobs that I do and stuff like that. So, definitely see the chat. I see a lot of people here in the chat. Thank you guys all for coming in here. Let me see if I'm missing anything. If I'm missing anything, definitely, repost it and I'll try to get to it. So, I'm going to, start off on my little sheet right here. I also have a little clip. Thank you very much for the super chat. I really, really appreciate it. Let's go with Bill. Bill, you had asked me a question. It was an interesting question. Bill is curious HVAC guy, and he had asked me a question about head pressure control valves. He sent me an email. You guys can all send me emails if you guys are curious about something, if you want me to talk about something. hvacrvideos@gmail.com. You can put them in the YouTube chat. You can put them in, all the different stuff, and I'll try to get to them, okay? Email might be the best one. YouTube comments are great too, but emails, I tend to go through those a little bit more. But anyways, so Bill had asked me about head pressure control valves, okay? So a head pressure control valve is a low ambient control. It's there to flood the condenser, or they may call them a flooded, it's there to flood the condenser to simulate a warmer day. Okay, so think of it as blocking off the condenser coil while it's running, so that way the head pressure is driven up to maintain a certain head pressure. Now, the reason why we use head pressure control valves is to maintain a set pressure differential across an expansion valve. Okay, so think about a standard TXV, or thermostatically controlled expansion valve, not a electronic valve. Okay, think about a standard TXV. It has a sensing bulb, it opens and closes, but something in the valve never changes, and that's the orifice inside the valve. Okay, so the orifice is always the same, but the superheat spring can apply more pressure or less pressure and push the diaphragm up and down throughout the valve, but the orifice inside the valve is always the same size. Therefore, we need a certain pressure differential across that valve. We need a certain amount of pressure difference between the inlet of the valve and the outlet of the valve for the valve to feed correctly. So we use a head pressure control valve in the system. Now, Bill's question was about what happens when a head pressure control valve bypasses. What does it do to the subcooling? Okay. So that's a really interesting question, and it really kind of got me thinking about it, Bill. I am definitely going to do some measurements, okay? And he's talking about the subcooling coming out of the receiver. Now, something to think about. Remember, we really don't use subcooling as a charging metric on refrigeration systems that have expansion valves, okay? Because typically we're just clearing the sight glass and we're looking for some subcooling coming out of the condenser, okay? If we have a clear sight glass, then obviously we have subcooling because, duh, okay? Subcooling equals liquid refrigerant. So, we need to make sure that we have some subcooling, but usually we really don't pay too much attention unless that subcooling number gets really high. Now, using subcooling as an overcharging metric is a great idea, okay? If you start seeing 30, 40 degrees subcooling, you got something going on, okay? Because you definitely don't want anything over that. But we typically don't pay too much attention to subcooling. But Bill's question is just kind of like a theory one, and it really has me thinking. So I'm definitely going to do some measurements myself to see. Stellar, thank you very much for that super chat. That's really awesome. You guys, I really appreciate those of you that, and I don't expect it from everybody, but I really, really appreciate the super chats. It's very, very awesome to see that you guys, will give your hard-earned money to my live stream. I really appreciate it. It does help me continue these streams, but it's definitely not needed, okay? But thank you guys very much that have chosen to do that, all right? So about the subcooling. So I'm going to do some measurements on that, Bill. I definitely want to measure that myself. I really think that once the refrigerant, like off the top of my head, once the refrigerant, because you've got liquid refrigerant already in the receiver, I imagine your subcooling is not going to really change too much because you've got vapor pushing down on that liquid refrigerant sitting in the receiver at all times anyways when that head pressure control valve is bypassing. So I imagine we're still going to have, somewhat lower subcooling, but I would like to take a measurement myself just to kind of see because it's not really going to help me with anything, but it definitely is an interesting question there, Bill. So, I don't know about increased subcooling, Matt, but we'll see. I'm going to measure it out and see how it works. I'm kind of curious how it goes. I would imagine that, being that the receiver is not really insulated at all, I would imagine the subcooling is not going to be very high. Because even if the vapor refrigerant was heating up that refrigerant inside the receiver, I would imagine that it's radiating the temperature outside of the receiver pretty quickly because the metal on the receiver is not very high or not very thick, so it's not really an insulation blanket around the receiver. Anyways, we're getting super techie and weird right now. I will definitely take some measurements and try to either report back on the stream or maybe put it in a video clip or something like that, and we'll go from there. Okay. Let's see. Marco, please talk about how you confirm a bad compressor or one that's on the way out. There's a lot of different ways to confirm a bad compressor, Marco, okay? First off, we need to understand completely how a compressor works, okay? Different types of compressors work differently. If we're working on Copeland compressors, we're going to use those ones as a guinea pig because Copeland actually has a really cool app called the Copeland mobile app that will help you to diagnose compressor problems, okay? So you can run numbers with the Copeland mobile app. You can input discharge and suction pressures. You can input amp draws, and it will give you essentially a pass or fail number and a percentage, and then tells you to look into the problem further, okay? So different ways. On old reciprocating compressors, we were able to do valve tests on them. We were able to shut valves and pump them down and check to see if valve pressures held and different things like that. But on scroll compressors, we really can't do that. So we definitely have to rely on the manufacturer's published data to help us diagnose compressor issues, okay? There's really a lot. I mean, that can go in so many different ways, bud. So if you want to talk some more about it, definitely send me an email to hvacrvideos@gmail.com. Give me some specifics, and I can talk to you a little bit more about it, okay? Let's see what else. Scott Savage, please explain supercooling. I imagine you're talking about subcooling. I am not going to do that off the top of my head right now because I want to make sure when you come to these technical terms that people ask me about, I understand superheat, subcooling, and all those different refrigeration practices. But sometimes if I'm going to be, really talking about it, I definitely want to make sure that I'm giving you guys the specific and correct terms. Okay. So that one I'm going to have to think about for a little bit, and then I'll come up with a proper diagnosis. I mean, a proper explanation that would make sense because sometimes what's in my head doesn't really come out of my mouth correctly. Okay. So let's keep going here. Let's see what he prime time. How come I don't cut out headmasters when I change a compressor? You don't need it. Prime time doesn't like head pressure control valves. I know it, but No, we don't really have too many problems with head pressure control valves here in Southern California. I've said it very much because we have a very mild climate, so we really don't see them bypassing too much. We just see them, you know, every once in a while. So I really don't have a lot of problems with the head pressure control valves, so I tend to leave them in. I have taken them out in the past in certain situations, but not something I usually do. I know you're just messing around, Primetime, but okay, so let's see what's going on here. Okay, so that's a good one. Brandon Tharp. Any information about adding exhaust fan extensions to get away from the condenser? So that's definitely a very HVAC rookie. Don't let me forget to answer that question. I'll get to it. So that's definitely a very important thing, Brandon. Okay. Exhaust fans. A lot of times we have exhaust fans that the building engineers, building designers didn't really think out too straight, and they set them right next to an air conditioning condenser. I have some videos on them where we have condensers that get covered in grease. Depending on what type, if you have high velocity fans, it might get the grease out of the fan and then it throws it all over the roof onto different things. Okay, so sometimes we will add hood scoops, extensions, different things like that to try to get the grease out of a certain area or in another direction. Just remember that, you know, you're going to push that grease into another place. And in all honesty, if they're throwing grease out of the exhaust fans, they really need to figure something out, because the way that hood systems are supposed to be designed is the grease is supposed to stop at the hood filters. So if it's not stopping at the hood filters, you know, there's something going on there. I mean, I see it. It does happen. We see really high velocity systems where they do throw grease all over the roof. It's not right, but it does happen. So yeah, you can definitely add hood extensions, but you would definitely want to lean on the manufacturer, because adding a hood extension is going to add static pressure to the system. And, you know, depending on how many bends or different intricate, you know, moves you make with that ductwork or that hood extension, it could be a problem. So you want to be very careful about just making something. Okay. You definitely want to follow proper practices. And like I said, talk to the manufacturer and see what they want to say, but that is a valid thing to do. We do often add a hood extension, whether it be extending the hood vent, you know, the discharge vent or whatever up, you know, 2-3 feet, or moving it over to another angle to get it to a different area. That does happen, and it is a common thing. Even the manufacturers usually will sell you a hood extension with their exhaust fan. So let me see what else we got in here. Oh, okay, so I definitely want to ask HVAC rookie, can a headmaster fail partially open? Yes, a headmaster can fail partially open. And what I'm going to do, gosh darn it, I have a headmaster that's cut apart sitting in my van right now. Excuse me, I would show it right now. But in a head pressure control valve or a headmaster, okay, just so that you guys know, oftentimes people will call a head pressure control valve a headmaster. Headmaster is actually Alco's trade name, I believe. Alco used to make a lot of valves. They're now Emerson valve. I don't know if they call it a headmaster anymore. I don't even know if they make them anymore. But anyways, Alco used to make head pressure or headmasters, and Sporlan just calls them head pressure control valves. So anyways, same thing, okay? But on a head pressure control valve, yes, they can fail partially open, okay? There's a very small little opening inside a head pressure control valve, and something can get stuck inside of there. And if it gets stuck inside there, the seat in the valve might not close all the way, and you'll be allowed to partially bypass refrigerant through the valve at all times. Typically, when you have a stuck head pressure control valve, if it's the summertime, you'll definitely be going off on high head pressure. You'll be able to grab the valve. The easiest way to diagnose head pressure control valves is with your hands, okay? Grab discharge line very carefully, grab liquid line, and grab liquid drain, and compare the temperatures. If you know the way that the valve operates, you'll be able to understand, hey, this one shouldn't be, you know, it shouldn't be hot going into the receiver right now. It should be the same temperature as the liquid drain. And, you know, you'll be able to tell really quick. But yes, they can fail partially open. They could fail completely closed, or they can fail completely open. It just depends, okay? In my opinion, the biggest problems that we have with head pressure control valves here in Southern California is improper installation or improper piping practices, or whatever you want to call it, brazing, different things like that. When the systems are installed, and then you tend to have things floating around in the system, and eventually it makes its way to the head pressure control valve, and every once in a while it can get stuck in there and cause some problems with them, okay? But, you know, I'm not saying that head pressure control valves don't ever fail on their own too. They definitely do. They can lose the dome charge, you know, all kinds of different things can happen. So let me see what else. All right, I'm going to go ahead and go to my list here. Make sure you throw your questions in caps lock. It really helps me to make sure that we get to them, okay? So something I want to talk about. Yeah, this is a funny one too. Someone had made a comment in my Linux video. So I am very hard on my tools. Okay. And someone made a funny comment that made me laugh about, when I was, I think I was putting a keyway or doing something on that Linux blower assembly when I was changing the blower wheels. And I took my Allen wrench or something like that and I used it as a hammer and I tapped on something. I use almost everything in my tool bag as a hammer. Okay. The only thing I've used my drill before as a hammer. I've used the battery on the bottom. Boom, boom, bang down on something. I use all my crescent wrenches. That's why I don't keep Knipex pliers. And because I don't want to buy expensive pliers, because most of my tools, they have to last through me beating the crap out of them. Okay. I'm not going to take my field piece meter and bang on something, but I guess I wouldn't put it past me to maybe tap on something with the field piece meter. I'm not going to expect, the field piece meter or my drill to hammer something like a nail in. But I mean, if I just need to tap something in, I just grab whatever. But with that being said, I only will buy certain tools because if I don't think that they're going to last with, and I'm being a little sarcastic about my meter, but I mean, using a crescent wrench or something like that, tapping on something with it. I don't like buying really fragile, fancy tools, expensive tools, especially because I usually beat the crap out of them, channel locks, different things like that. And I also am careful too, though. Like for instance, I learned really quickly on a set of channel locks and a set of crescent wrenches or adjustable wrenches to not hit on the little knob that you move, because then the wrench is useless. Okay. So I'll usually use the correct part that I can beat on something, but just one of those funny things that I do. And it makes me laugh when I see those comments about that. So, okay. HVAC our vlogger, that's Ernesto. He asked me if I think that social media is making the trade more appealing to the younger generation coming up. Yeah, definitely. I definitely say that social media is helping. I think that YouTube helps a little bit. And I know that because I see it in the comments of my videos. A lot of the people making comments on my videos are people in trade school. And they're like, wow, I stumbled across this. It's really cool. And then I usually direct them and tell them like, hey, there's so many other people making videos. Okay. But social media for sure. I'm really not a fan, and not judging anybody else, but I'm not a fan of I don't really see a lot of use in Instagram for but I guess I shouldn't say that. I mean, Instagram's a cool place to chill out and talk about different things. I just don't know if there's a lot of education on Instagram, but I guess that's probably not a correct statement. I think there's some people on there educating, but yeah, I definitely think that social media is making the trade more appealing for younger people. Sure. I don't think it's enough. I think that we still need more help. I think that where we need to start is on the high school level. I think that we need to start recruiting from high schools. Something I've been talking about for a very long time and wanted to do myself, I just haven't had the time to do it, is go to the local high schools, talk to the school districts, talk to the teachers that talk about careers and different things like that, and be able to go in front of the students and talk to them there, because I think we need to grab some students before they're shipped away to these fancy colleges and get them into the trade, because we need something, or trades in general, I think. But social media is definitely helping. Social media can also be bad too, because people see some crappy people making videos or different things like that. And, again, I'm not trying to judge different people, but I'm just going to stop talking about that. All right. Aldo, you asked me if I install walk-in coolers from the ground up. No, I don't do any new installations. The only kind of installations I do is typically retrofits. I don't do any new construction or walk-in replacements. I'll tell them to get a construction company out there to do the walk-in. And then I don't mind putting the refrigeration equipment in it. But I've just never wanted to really get involved in doing walk-ins. There's too many things that can go wrong. There also can be really easy money. I do understand that, but I've seen walk-in installations go really bad and cost people a lot of money. So I'd rather not be the responsible party. What I've seen is where I've done refrigeration equipment, but another contractor did the walk-in installation, and they installed everything. The restaurant had started up, fire sprinklers, alarms, plumbing, everything was done. And they realized that they didn't install the walk-in on a level surface, and they had massive air leakage, and no joke, that contractor ended up filing bankruptcy. So it's things like that. There's a lot of mistakes that can be made, and I just leave that to a construction company to do that stuff. So just my personal preference. Let's see what else. Who do I watch? Scott Savage. There's a lot of people that I watch on YouTube. What you can do is you can go to my YouTube page and YouTube youtube.com/HVACR videos, and there's a little link on there called channels. You can click on that and you can see all the channels I subscribe to. Now, the one thing I will be careful to tell you is that sometimes I subscribe to people that aren't the greatest people either, just because I like to chuckle and watch their videos. But so just be cautious about what you don't just assume that just because I subscribe to them, they're the best person in the world. But yeah, you can go to hvacrvideos.com or youtube.com/HVACR videos, and then click on the channels link and you can see all the different people that I subscribe to. So let me see. All right. So another thing I want to talk about is I'm going through my list right now. Okay, cool. We're good right there. So I want to talk about mentally preparing for the job. Okay, so mentally preparing for our jobs, being ready when we go to the jobs as much as possible. Now, you can overthink jobs too. For instance, when I'm going to a service call, I don't have an apprentice riding with me right now, but in the past, I've had an apprentice riding with me. And the whole way there, he's asking me, what do you think could be wrong? What about this? What about that? When I'm going to just a general service call, there's really not much thinking in my mind unless I have a lot of details about the job. But when I'm going to do installations or compressor replacements and stuff like that, I try to think about the job. I try to make it more efficient. I'm sure you guys see that in my videos. I try to be as efficient as possible when I'm doing things. And, I've said this before, but I always try to think of the worst thing that can happen so that way I can be prepared for it. One of the really, really big tips that I would give to anybody that's in the trade is one of the most important safety things that you can do is to learn how not to react. And what I mean by that is when and if something bad happens, because it is going to happen. There is going to be stuff that goes wrong when you're working. We work in a dangerous environment, so stuff happens, okay? When and if it does happen, you have to learn when it's correct to react and when it's correct not to react. And I'm going to give you an example. I think I've said this before on the stream before, but it's really important. I'm going to tell you one time, this was a long time ago, my dad was brazing on a piece of pipe. This is when I was younger, and I remember him coming home from work and it was not good. He was brazing on a piece of pipe on a vertical. Okay, so it was a vertical piece of pipe, and he didn't support the bottom of the 90. And while he was brazing the pipe slid out and dropped. And his instinct was to grab that pipe. He grabbed it with the palm of his hand, and he got horrible burns on the inside of his hands. That's an example of a time when you have to learn how not to react. It's very hard because your instincts tell you to, oh, something's falling, grab it. Same thing. I'm going to give you an example. Working on a carrier package unit, okay? And I'm trying to put my service gauges on a 10-ton carrier package unit. Well, you have to pull the panel off. The condenser fan motors are right there at your face. And you've got to screw your manifold gauge set on there, and maybe you can't shut off the unit. Well, you're working with your hand about 4 inches away from the condenser fan motor blade that's spinning quite fast, okay? So what happens if while you're screwing that on, something drops, a loud noise happens, the compressor starts up, someone drops something behind you, and you get scared and you jam your hand up into the condenser fan motor? That's an instance where I say that you have to learn how not to react. It does take time to get to that because at the same time, you have to know when to react too. For instance, if something's going to fall on you, you have to know when to jump out of the way. But that's a very important thing. And that will come, for you newer guys, that will come with experience. You'll learn how to do that. But it's very important to understand when not to react so that way you don't hurt yourself, okay? Understand that if you, in a perfect world, you cut a compressor out every single time you change it. But we don't live in a perfect world. There's many times where I have to unbraze a compressor. So there's no refrigerant left in it. The ports are open. You got to heat it up and you got to pull the suction line off while it's hot and different things. It's pretty much guaranteed that when you're unbrazing a compressor, you're going to get a flame out. And what a flame out is when the oil inside the compressor ignites, okay? And it will shoot. I've seen them shoot quite a ways sometimes, depending on how big the system is. And if there's even the slightest bit of pressure still in the system, that oil, once it ignites, will shoot even farther, okay? Things like that. That's why when you follow your proper safety practices, you wear your PPE, all the protective crap, right? You have a fire extinguisher with you. You have a wet towel. You have a water hose. You have something there to help you when you're brazing, okay? Things like that. Learning how not to react, but then also expecting certain things that are going to happen. So whenever I'm unbrazing a compressor, I'm always ready. Like, this compressor is going to flame out. I have a feeling it is. be prepared, okay? You can move wires away from the area. You can make sure that there's nothing that's flammable in the area, things like that, okay? So you got to be cautious because you want to go home at night. Now, I don't know the circumstances, but there's a very, very, I don't want to confirm the person's name because I just saw it on social media. I don't know if it's completely true, but there's a couple different people on social media talking about a really big Instagrammer that is an HVAC Instagrammer that passed away. Okay, they were talking about it on Instagram today. I haven't gotten confirmation, but who knows how he passed away, what the circumstances are behind it. But it's really important that we go home at nighttime, okay? We do work in a dangerous job, and there's elements of it that can be very dangerous, climbing ladders, different things like that. We need to take our time. We need to make sure we're being careful because we need to go home at nighttime, okay? All right, let's see what else we got. How does so Carlos Cervantes asked me, how does a thermostat work with a control board that has terminals GC and GH? Saw it in an old pane. That's an interesting, that sounds like a, I'm not too familiar with the old pane board, but I don't know what the GC and the GH mean. I'd have to look at a schematic. So let me see what else. What if I missed something, guys? Throw it in here. So whatever happened to my helper, Ernesto. So the guy that was working with me, unfortunately, I had to let him go. He was a great helper. He was doing really well, but he had some personal things going on, and it just wasn't working out. But he didn't do anything wrong with our company. He didn't do anything wrong while he was working on the job. It's something that happened in his personal life, and we just couldn't keep him employed with us. So it's very unfortunate, but it's just one of those things. That's what happens oftentimes as a business owner. That's a very frustrating thing when you have employee turnover, people leave, people come. That's something you have to get used to, but it also hurts every single time. So because I had an apprentice working with me, and essentially when you look at it from a business side, I made a commitment to have him work with me, and I wasn't going to make a dime off of him because essentially I was paying him every day to come to work and I wasn't billing for him, right? Don't get me wrong. I made a couple bucks, but still, and I'm training him. And then unfortunately something happened and we had to let him go. And, things like that happen, but it does suck as a business owner. So. All right. Let me see. Anybody get the movie quote yet? There's a movie quote popping in. I don't know if anybody got it yet. Haven't seen anybody say it yet, but all right, let's see what else. Okay, there you go. Retread. Retread says GC stood for fan cooling and GH was for fan heating. So cool. No, I have not worked on boiler systems, Matt. Sorry, bud. Okay. Let me see what we got here. Molly, what is this? What are you saying there, Molly? You can answer questions from head pressure, compressor, condenser, evaporator, expansion valve, exhaust fans, oil burners, to receiver dryers. Molly, I'm going to go ahead and remove that comment. No offense to you, Molly, but no, I don't think that you can answer questions about head pressure control valves and stuff. So let's leave the questions to the other people. Again, no offense to you, Molly, but we're just going to take that out of there. Okay. All right. So I'm going to go ahead and get to a couple other things. So, this was another really good one too. So AC Nickerson had asked me, and this was on the last live stream, I believe. He had asked me about my first solo service call, to talk about an early service call. Okay. So, I can't remember my first service call, but there's a very memorable early service call that I had where I failed miserably. At the same time, I'm not going to talk crap, but there was some circumstances that went into my failure that probably weren't my fault. So I was working at a very popular Mexican restaurant chain. They still do exist. I don't do work for them anymore, but I'm not going to name the chain. But and we had a remote refrigeration system. It was a cook's drawer unit. It had a stainless steel expansion valve. And I was still very, very new in the trade. I was not very familiar with brazing. I definitely brazed a few things, but I wasn't very familiar with it. I'd worked with silver solder before. If you don't know, when you're working with dissimilar metals, copper to stainless, copper to brass, you need to use a silver bearing solder, a high silver bearing solder. I'm a 56% fan. with silver solder flux. But anyway, so essentially I needed to replace an expansion valve, and actually, no, I think I was fixing a leak on the expansion valve, and for the life of me, I could not get the weld to take, okay, or the braze joint to take, and it was a stainless steel valve. So I know what I did wrong, and I know what I was doing wrong, but it's one of those things where I wasn't properly trained, okay, and this is where I feel like we throw technicians out into the field a little too quick. We need to give them a little more practice. I'm not a fan of the sink or swim. I know that a lot of people did good with the sink or swim. In fact, I was a product of sink or swim. I was thrown out there and I had to figure things out. So I was trying to braze in that stainless steel expansion valve, and for the life of me, I could not. And I must have been on the job. I can picture the day, and I could picture it being 3-4 hours, something like that. But it took me a long time to. Yeah, it was Anthony D. Very cool, man. Con Air. So it took me a very long time, and I could not get the weld to take, okay? So I ended up having to have my dad come out, and he was pissed off and mad at me because he had to come out. And what it was, essentially, was I just wasn't heating the valve up enough, okay? And it's just one of those things where I'd seen it done so many times, but I just hadn't done it enough myself. And that was one of the early service calls, and I still remember that one to this day. There's also another one where I can remember being a little kid. I wasn't even in the field yet. I was a little kid working with my dad. We were working at that same Mexican restaurant chain, and we were working on a package unit on the roof. And for whatever reason, I don't know what my dad was doing, the unit was still live and energized, and he gave me a control wire. And I was probably 9 or 10 years old working on the roof. Again, you know, things were way different back then. I went to work with my dad when I was 10 years old. But anyways, I was working on the roof in a package unit, and my dad gave me a control wire. It must have been an R wire or something. And he told me to hold it and don't let it touch anything because he needed to go downstairs. And of course, I'm a 10-year-old, right? And I'm looking at this wire. It's control voltage. I know because I can picture everything about it now. So it's just 24 volts. But I'm looking at it, and he says, don't let it touch anything. Well, what do I do as a kid, right? I'm sitting here thinking, well, why? So I take that wire and I touch the cabinet of the unit, and it makes the tiniest little spark. I can remember the spark. And then I instantly felt regret and felt like I was in trouble. And I remember my dad was so pissed at me. He was like, God damn it, you know, whatever. But it was just the funniest thing because I was a 10-year-old kid, and my dad told me not to let it touch something. And I was curious what would happen if I let it touch anything, you know? That's another early memory that I remember as a kid too. So, all right. All right, let's see. Yeah, definitely, Ernesto. I mean, getting thrown in that quick, man, that can definitely cause, you know, be difficult. So, let's see what else. No, and guys, don't. I appreciate it, Molly. There's nothing wrong, Molly. It's just, you know, guys, don't start crap or anything. Don't be offended. It's just, yeah, just let me answer the questions, okay? So, all right, so I want to talk about, someone had asked me about 3-in-1 start kits. So, and I've talked about these before. Rito Felix, you asked about 3-in-1 start kits, and he wanted to know how I size them and different things like that. I am not a fan of using start kits, okay? And I wish I had one here to show you guys, but I'm talking about, like, for instance, I'm going to throw Subco under the bus, and I use them, but for a specific use, okay? So Subco has a 3-in-1 start kit. It comes with a start capacitor, and overload built into, or actually it doesn't have an overload. It's a start capacitor and a relay built into the little kit, okay? And it basically has a couple wires. You hook it common, start and run, and it'll get your compressor going. They usually rate them in different horsepowers, but here's the problem. If you've ever taken apart a refrigeration compressor, okay, so let's just say you take apart like RST64 or something or other Copeland compressor, and you go to Copeland and you say, what's the horsepower of this compressor? And they say it's a 3/4 horsepower compressor, okay? If you go get a 3-in-1 start kit for a 3/4 horsepower compressor, I don't even know if they make them that big. Like, you could just say a 1/2 horsepower too. But if you go to get a 3-in-1 start kit for, let's just say, a 1/2 horsepower compressor, it's not necessarily going to have the same start capacitor as what the manufacturer has on their compressor, okay? So they will oftentimes get you out of a bind, okay? I will use 3-in-1 start kits to start a compressor up, All right, but that's about it. If it starts and it runs, then I will take the 3-in-1 out and I will go get factory starting components. I'm not a fan of leaving 3-in-1 start kits on compressors. That's my personal preference, not judging you guys, but I tend to notice a lot of problems. They tend to cause overheat issues, especially when they're not sized correctly, and it just creates havoc. So I'm not a fan of using 3-in-1 start kits. That's just my personal preference. So, all right, let's see what else. Untamed. You said you watched my Delphi prep table with me changing the power head under pressure. Never knew that was possible. How much refrigerant was lost during? So that is a really good question, Untamed. Okay. How much refrigerant is lost if you change a power head under pressure? Let me ask you this other question. How much refrigerant is lost when you hook up a vacuum pump to a system and you evacuate it properly? Okay. I'm not saying that I am perfect. You have to make a judgment call on whether or not it's worth it for you to do a hot swap and change a power head under pressure. Oftentimes, if I do a hot swap, the amount of refrigerant that's lost is so minute, in my opinion, this is my opinion, it's going to be less than if you hooked up a vacuum pump and properly evacuated the system. That's after you've recovered or after you've pumped the system down or something like that, because there's always going to be refrigerant stored in the little pockets in the unit. There's going to be refrigerant stored in the oil. So if you pump down a system to a very, very low pressure, and swap out the power head really quick and you have everything prepared, I can have a power head swapped out, no joke, in like 5-6 seconds. Twist it off, twist it on, be done. Okay. And in my opinion, I'm losing less refrigerant than if I was to hook up, to pump the system down and hook up a vacuum pump. Now, I don't do that often. There's only certain situations where I'm going to do that, but you need to be very cautious about that, and make sure that you only do what you're comfortable with. So let's see what else we got here. Okay. I'm sorry, Jenny. Just let me see what else I got doing here. Yeah, just type your question again if I missed it. It's hard for me to scroll back up. So, let's see. Oh, okay. All right. You got it answered then. Okay. So, prime time. Your father was a very harsh teacher, still is, but it's the best way. There's arguments to be made both ways. So yeah, I was raised by, a very harsh person, but he was a very smart person and taught me everything that I know. So, it is what it is. So, but you also got to understand too, in prime time, things are different. And the younger generation coming into the trade, this is my opinion, the younger generation coming into the trade can't handle that harshness anymore. And yes, we would think we all went through it. Why can't they? But things are different. The younger generation doesn't take crap anymore. So if it's not easy and spelt out for them, a lot of times they're going to walk away. So, all right, let's see what else. Does Canada use the same refrigerants as we do in the U.S. market, or do they use HCs like European countries do? You ask because you're looking to move outside of the USA market. That's a really good question. Hey, guys in Canada, I mean, they pretty much use the same refrigerants. They follow the Montreal Protocol. I would think that the European market would use some of the newer refrigerants a little bit more than Canada would. But guys, anybody that's in here, Joe, you guys use pretty much the same refrigerants. You guys have the same R290 crap popping up. And, are you guys phasing out refrigerants faster than us, Joe? Joe will answer there. So, guys, if anybody in here has questions for Ralph, I saw someone mention Ralph's name in here. I'll post it in here right now. Here's his email address. Ralph works for Honeywell Refrigerants. So, let's see what else. Oh, okay. So Joe65, great question. I saw your comment about that too. So he asked, when I increased the fan speed on the AC in today's video, did I mess up the balance in the building? Yes. Okay. If you do adjust fan speed on an RTU or a package unit, it is going to affect the balance in the building. Now, I can tell you that I didn't get it on video, but I did check the balance. And in fact, that building was already running in a negative air balance. So by me correcting the fan, it actually helped. Now, if you paid attention to the video, look at back in the beginning, look at how low my airflow was. I think that someone adjusted the airflow to compensate for the plugged up metering device. So that's definitely, I think that was part of the original problem. I don't know what they were doing because the airflow was really low on that unit. So by me adjusting it, I got that unit back up to specs. But yes, it did affect the balance, but it actually helped the balance in my situation. So you do need to be very careful on situations like that. You don't want to mess with building balance without knowing what you're doing. So, and I half-ass know what I'm doing. So let's see what else. Yeah, prime time. Yeah, so it is old school. We have to do some things. Things are different now, so we have to tailor a little bit to the younger generation. And I'm part of the younger generation. I was just raised old school. So I'm only 36 years old. So it's my generation that majority of the time is the problem. There's a lot of people, sometimes younger. I like to think that I'm not a millennial. I think technically I am, but we gotta change the way that we think because the younger generation is different. So let's see what else. All right, let's see what else we got going on. Okay, so let's see what else. Do I recommend hard start kits? I'm not a fan of hard start kits. I have put them on. There's a difference between a 3-in-1 start kit and a hard start kit. A hard start kit, in my opinion, is there to help a compressor once it's starting to fail. So, I'm not a fan of hard start kits, but I mean, as long as the customer knows that the compressor's on the way out, then yeah, I'll put a hard start kit on there. So let's see. Okay. Oh, definitely. DJ Subair. Did I always have the attitude for the bigger picture when working with my dad? Yes, I did. Okay. So my dad doesn't work in the trade anymore. I shouldn't say that. He works in the office. He doesn't work in the field anymore. Okay. So he's still involved, but yes, I was looking at the big picture when I worked with my dad. Now, my dad taught me he gave me a lot of the mentality of looking at the big picture, but being raised by an old school person, I wasn't given a lot of details. Okay. And nothing against him. It was a different time. The trade was different. Okay. I wasn't given a lot of details and I wasn't given a lot of answers that I needed. So it really sent me looking for the answers. So, why are we changing all these parts in this machine? Well, because we've got the refrigerant out of it and, I'm not, and essentially we weren't super confident on what the problem was. So we changed these parts. Okay. Again, I'm not talking crap. Okay. Things were different. That's how you troubleshooted and diagnosed a lot in the past. I didn't really like that. And that got me really thinking more about the big picture too. So the big picture diagnosis definitely comes from my dad. He taught me that, but then also he got me thinking about more things because I couldn't get certain answers and different things from him. Okay. And again, I can't stress enough, guys. I am so thankful for everything that my dad taught me, and I'm not talking crap on him. It's just, I'm pointing out the fact that he was an old school technician and things were different then. Okay. And there was things that people didn't know and were taught. For instance, coming up in the trade, I've said this before too. I was taught to charge an R22 air conditioner by blocking off the condenser, getting the head pressure to 275 PSI. And when I did that, my suction pressure should be 65 PSI flat out. That's how I was taught. And it worked when we had really low SEER equipment, but that was not correct. We should have been using target superheat, okay? Because we did not have a lot of TXVs and package units at that time. It was all fixed orifice or capillary tubes, and we should have been using target superheat. But that got us by. The equipment was very forgiving. Nowadays, it's not forgiving. We can't do that kind of stuff anymore. So we need to be more thorough. We need to be looking at everything. So, okay. All right. I'm going to go ahead and play a little video clip for you guys. Let me go ahead and pop this over here real quick. Let me pop this up. And I had a question today about, liquid injection valve on a Heatcraft condensing unit. So Heatcraft uses a different type of liquid injection lately. They're not using a standard DTC valve, and they're using a capillary tube type liquid injection valve. So someone had asked me about it today before I went on the stream, and I happened to have a condensing unit sitting at my shop. So I am going to go ahead and play a clip for you guys right now. Let me go ahead and click this over and click this off. Click this off, and I'm going to go ahead and play this clip for you guys, and then I will be right back. All right, excuse my mess. Back of my shop is a mess right now, but I wanted to talk about something. I've talked about these a little bit before, but we have something that we add to scroll compressors oftentimes on low temperatures. You can do it on medium temp too, if you have a refrigerant that runs high discharge temps, but especially on low temperature scrolls, because they have higher compression ratios, the compressor typically doesn't get enough cooling going back to the compressor. So you can have overload issues. What we usually do is we have some sort of secondary cooling coming to the compressor. Most of the time you'll see them factory installed on a Copeland compressor, something called a DTC valve. discharge temperature controlled valve, basically, okay? And this one... My bad, sorry about that. Mess. Back of my shop is a mess right now, but I wanted to talk about something. I've talked about these a little bit before, but we have something that we add to scroll compressors oftentimes on low temperatures. You can do it on medium temp too, if you have a refrigerant that runs high discharge temps, but especially on low temperature scrolls, because they have higher compression ratios, the compressor typically doesn't get enough cooling going back to the compressor. So you can have overload issues. What we usually do is we have some sort of secondary cooling coming to the compressor. Most of the time you'll see them factory installed on a Copeland compressor, something called a DTC valve. Discharge temperature controlled valve, basically, okay? And this one, though, has a little bit of a different valve, and I get questions. I actually just got a question about this today, and I had one of these sitting at the shop, these Heatcraft condensing units, so I figured I'd pull this apart and show you guys, okay? This is a, first off, Heatcraft, you do a great job of soldering in your fittings. That's absolutely stupid, right? Dumbest crap in the world. But anyways, this is a liquid injection valve. This is a little bit different type of a liquid injection, okay? What it does is it's feeding all the time, okay? Unlike a DTC valve. A DTC valve is a temperature controlled valve that basically inserts a probe or a sensing element into the head of the compressor, and whenever the head of the compressor gets to a certain temperature, the valve opens up. Well, this one essentially is just like using a capillary tube, okay? It's just a metering device, and all that it is desuperheating the liquid refrigerant, basically, and basically metering it into the head of the compressor and cooling off the suction of the compressor, and it's helping to basically cool it, okay? So this one right here, though, it uses you see a solenoid valve here, right? And you can see this is our liquid line. So once we pipe this in, it's going to be piped off of the liquid line coming out of the receiver. After the sight glass, it flows into this valve right here, the solenoid valve, and then it goes up into our liquid injection valve, okay? Now, this one right here uses a current sensing relay right here. In these Heatcraft condensing units, you've got this current sensing relay. Whenever the compressor contactor pulls in, it grabs one leg off the compressor contactor, senses the current, it opens up that solenoid valve right there, okay? Now, if you didn't have this solenoid valve here, you would never be able to pump this system down, meaning that, you know, if it went into defrost or anything like that, it would never pump down, because this valve is always going to meter into this compressor. Therefore, we have to have that solenoid valve, and we have to have something to turn the solenoid valve on and off, and that is our current sensing relay that is right over here. Okay, so if you ever open up these Heatcraft condensing units, that current sensing relay is for this solenoid valve, and it's there to open it so that we can provide cooling to the compressor whenever the compressor is running. If we didn't have that there, you could also put like a ball, well, no, you couldn't actually, but I have read some documentation on using the DTC valves. Okay, that's the one that has the element that goes on the top of the compressor. In the installation instructions, it says there's no need for a liquid line solenoid valve, because in theory the head of the compressor is not going to be that hot when it's pumping down. But if you were worried, they said it's not a bad idea to install a solenoid valve before the DTC valve, okay? Again, this is not a DTC valve. The DTC valve mounts on the same rotolock fitting right here that Heatcraft butchered when they soldered it or brazed it shut. The DTC valve mounts on there via a rotolock fitting, and then a sensing element comes out the top and goes into the head of the compressor, and then it only opens and closes the valve. So it works just like an expansion valve. This one essentially is just like a capillary tube, just feeds refrigerant, you know, meters it into the compressor to help with the high discharge temps when we get high compression ratios, to help cool the compressor. Yeah, so hopefully that makes sense for you guys. All right. So those valves can be very confusing to a lot of people, and essentially just think of it as an expansion valve, okay? It's a de-superheating expansion valve. It's there to help with the high discharge temps, to lower the compressor's crankcase temperature, essentially, okay? Because of the high compression ratio on the compressor, you have that huge difference between suction and discharge. You know, it causes heating issues with it. So hopefully that helped you guys out and made sense a little bit. Okay, so John, thank you very much for the super chat. Okay, so you said you sent me a question on today's due to the character limit, wondering if you wouldn't mind taking a look. Keep up the great videos. I definitely will, John. I don't know that I have it written down, but I will definitely address it. And don't let me forget to get back with you, okay? Any of you guys, if you email me, don't hesitate to email me again if I don't answer. Hey, Bill, thank you very much, man. I really appreciate that. Really, really appreciate that, guys. Bill has a great YouTube channel, too. And so does HVACR North. There's a lot of great guys in here that have YouTube channels, okay? So definitely look around. All right, let's see what else. So the solenoid valve is also used for defrost, Carlos. No, it is not. On the that liquid injection valve, that solenoid valve, Joe, thank you very much, man. That solenoid valve is only there to allow refrigerant to flow through that liquid injection valve while the compressor is running. Okay, so on that particular system, that solenoid valve is only there for the liquid injection valve. We have another solenoid valve, a pump down solenoid valve installed further down in the liquid line. That'll typically be installed down in the evaporator section close to the expansion valve for the most part, okay? So on this, that is a walk-in freezer condenser. On that system, there will be two solenoid valves, one on the liquid line going to the expansion valve and one for the liquid injection valve, okay? Because that liquid injection valve feeds liquid refrigerant directly into the suction line or the crankcase of the compressor. If that liquid injection valve was allowed to run all the time, okay, then when the system would try to shut down during defrost or via temperature controller, it would never shut down because we'd be constantly feeding liquid refrigerant. Chad, thank you very much, man. I really appreciate it. You guys are awesome with these super chats. So hopefully that makes sense for you there, bud, okay? But yeah, so the liquid injection valve on that particular type. Now, if it's a DTC valve, that's a discharge temperature controlled valve. That valve does not need a solenoid valve because it'll open and close based off of the head of the compressor's temperature. So when you're pumping the system down or it's pumping down on, or it's satisfying because of the temp control, the head of the compressor is not going to be as hot. So therefore the DTC valve won't open. Okay. So, but with this style liquid injection, you got to have that solenoid valve and you got to have that current sensing relay. Hopefully that makes sense. Okay. The super chats. Thank you guys so very much. Okay. So throw some more questions in here, guys. I'm about out of my, my prepared topics. Okay. And, let's get to anything else that you guys have in here. Okay. How do you correctly size an expansion valve? So I'm going to direct you to Sporland's document on sizing expansion valves. What you want to do, yeah, you can have a DTC valve on it. It's not necessarily always on low temp. Now be careful because you can also have something that looks like a DTC valve, but it's capacity control. So be cautious about that. Okay. There's a couple different types of valves. Okay. So you can have kind of an unloader valve too. That's like capacity control. There's different things. So be cautious about assuming they're all the same. But yeah, you can have them on different stuff. I've seen them on medium temps and all kinds of stuff. Okay. Let me see. How do you buy HVACR merch? So, I don't have any HVACR merch for sale. At one point in time, I had given out a few shirts, but I'm not selling anything at this time. Okay. There's a possibility I might do something in the future, but the reason why I'm not selling it is the nightmare of sales tax. Sales tax is a disaster and just trying to figure all that stuff out. So, what's the reason for the suction line check valve on that compressor? That's a really good question. I've started to notice that they put those check valves on there. I don't know the exact reason behind them, but you know, yeah, it's hard to say. Maybe, yeah, I don't know. I'd have to think about that one there. What's the oldest piece of equipment I still service in use? Lately, Mr. Ice, it's probably something from the mid 80s. I still have, that I know of right now, 3 R502 systems that were probably from 88, 89. I don't have anything any older than that right now, I don't think. I've removed equipment from the 60s about 7-8 years ago. I removed some package units from a Joe's Crab Shack in, where was it? It was a Joe's Crab Shack in Long Beach. I removed some Carrier split systems that were from the 60s. Those were pretty cool. Those things were dinosaurs, man. It took us like 2 days just to get the equipment out of their attic. It was in an attic and it was a nightmare. They were 10-ton package or 10-ton split systems where the compressor was below the evaporator, but the condenser was on the roof. Those were some interesting ones. But yeah, so right now I'm just dealing with the stuff from the 80s. Retread, does my father watch my videos and does he give me any feedback? He's seen my videos once or twice. He's really not interested in the trade, so I don't think he watches them to like you guys might watch them. He likes them. He thinks that they're great. I mean, you know, that's about it. Let's see what else. What's the best way to diagnose and adjust an EPR valve? You know what? I'm not an expert on an EPR valve. I've only have maybe 2 or 3 systems that have EPR valves, so I'm not even going to touch that one, Mr. Ice. That would not be my forte to be talking about those things. So let's see what else. How to tell the difference between high limit switch and loss of charge switch. Usually on the side of the switch, you can, well, first off, a high limit switch is going to be on the discharge line, okay, or on the high side of the system, typically not the liquid line. They're usually going to be on the discharge line. A loss of charge switch is typically going to be on the liquid line, okay? But no, yeah, I mean, it depends because what do you call a loss of charge? So Carrier calls theirs a loss of charge switch. They don't have a low pressure control. They call it a loss of charge switch. Essentially, it's a low pressure control, but they install it on the liquid line, okay? So what you can do is oftentimes on the pressure control, they'll have numbers written on the side like the cut in and cut outs, and so that'll kind of tell you a little bit. High pressure for R22 is typically going to cut out at 410, 450 PSI, and then high pressure on 410A is going to typically cut in like the 600 range. Loss of charge switches, they're going to be much lower than the 400 range. That's just a silly thing that Carrier does. I know there's some other people that use loss of charge switches too. I prefer to see a low pressure switch. So that way, if you have a plugged up metering device, you're going to shut off on low pressure essentially before the loss of charge. So in my opinion, I could be wrong, but just my point is that a loss of charge switch will allow that compressor to run for quite a long time before it shuts off. So, all right, let's see what else. Definitely can turn these guys off because you guys already got the movie and it was Con Air. So I'll turn the Nightbot thing off so that way it doesn't keep telling you guys the dang same movie. Let's see what else. Do I service my own HVAC system? My HVAC system is horrible, guys. It is a horrible 4-ton system that was installed before I moved into my house. I tolerate it. It's so loud, it's ridiculous. If we shut off the fan to my split system, my whole family wakes up because they're so used to hearing the sound. It has horrible high static pressure. The airflow is crappy. It keeps my house cool, but it kind of short cycles a little bit. So that just goes to show you that, you know, us HVAC guys don't always necessarily have the best operating systems. It does what I need it to do. It's probably not very energy efficient. One of these days I'll make a video of it and show you guys how horrible it is. It's an Arco Air system, and I don't think that my house, I think I did a load calc on my house one time, and I think it only needs a 3-ton, and there's a 4-ton in here. So, yeah, it's one of those. I've just never changed it. All right, let's see what else. HVAC Rookie. See you later, bud. Thanks a lot. All right. How do I get an airflow reading on Measure Quick? So Measure Quick kind of does it for you so long as you have your air probes inside the system. The ambient temperature or the return air temperature, I believe, has to be above something like 70 degrees, something like that. But it'll calculate the airflow once you input your tonnage in the unit. You have to input all the numbers, and then it does the airflow reading for you. And it's pretty darn accurate with Measure Quick. It's really accurate. So let's see what else. What's my worst refrigerant burn? I've never had anything that blistered, in all honesty. So I can't really say that I have a really bad refrigerant burn. I'd say most of my burns, you probably can't even see them. You guys can't see this, but I have this mark right here on my arm where I was soldering with some plumbing solder, and the solder dripped on my arm, and I let it sit there for a second, and then when I went to go pull the solder off, the skin came with it. So I have this like awesome little weird shaped scar right here. But no, just discharge line burns and things like that. But I really haven't gotten a refrigerant burn all over my hands. I've been lucky enough, cross my fingers. So thanks so much there, 716 Appliance Guy. I really appreciate it. Any other questions, guys? Throw them in caps lock. I'll try to get to them. Let's see. Let me see what else. Will I ever do a shop tour? So my shop isn't really anything to say, guys. My shop, we operate our business out of a house. Nobody lives in the house, but we operate it out of a house. So, I mean, there's really not much to see about my shop. I can show you my garage. It just has a crap ton of parts in it. And then back behind my shop is a big giant yard. We live in like an unincorporated area. So we have a house that's kind of behind my house that we operate our shop out of. So, not really much to show there. Let's see. Any advice on troubleshooting water coil unit by geologic heat control HPC tripping? If your HPC is tripping on a water unit, majority of the time your heat exchanger is going to be fouled. I'm not an expert on water source heat pumps or anything like that, but I can pretty much tell you if you're tripping a high pressure control, you've got a fouled condenser somewhere. I don't know if you have a closed loop or an open loop. Again, I'm not an expert. Maybe there's some other guys in here that can answer. So, do I know where to buy a compressor start cord? Frank Bradley. Hey, actually, Frank, hold on. I will post a link because one of my buddies on Facebook was asking me that exact same question. The compressor start cord that Super Dave NorCal Refrigeration uses was asking me, or one of my buddies was asking me about that start cord. And I didn't think you could buy them anymore, but he found them. So hang on just a second. I'm going to pull it up right now and put the link in the chat. Or at least, you know what? I'll tell you guys where to find it. Let me find this chat message that I had with my buddy today. And he got it from a company called, hold on just a second, techinstrument.com. So I'm going to type that in here right now. So techinstrument.com is where he got it from. And give that a check it out. And they have, it's called here's the part number for the cord, SS-C6 start switch. That's what it's called. Look that up on there. And you can definitely find one of those start cords. I personally don't use one of those, but I've had a lot of people ask me about that, and he found it. So caps lock for sure. Anyone ever have scary disconnects or had breaker turned on in the middle of working? Yeah, definitely. I've had scary disconnect switches. There's a lot to be said about lockout, tag out, and mechanically locking your breakers off to where nobody can turn them on. I've had disconnect switches that were wired in backwards where the line voltage came in the bottom and the load came out the top. So therefore the fuses were energized 24/7. Luckily, I've never been electrocuted by it. Again, big picture. You don't ever assume that everything's the right way it's supposed to be. So you always approach any kind of electrical system as if it's not wired correctly. Always check voltage, always verify. Always want to lock out, tag out, make sure that your equipment is locked out so that way nobody can accidentally turn it back on. Nobody wants to get hurt. So I've never had any specific situations where someone's turned on a breaker on me or anything like that, but definitely something you want to do. So have I ever found the wrong refrigerant in a system? How did I do? Oh yeah, I've definitely found the wrong refrigerant in systems. I have videos on that for sure. I took over a customer sometime last year, maybe the year before, and we had a lot of package units where it just wasn't making sense. The refrigerant pressures were really wonky. There's a couple package units are a little bit easier to find the incorrect refrigerants or mixed refrigerants in. The easiest way to find a mixed refrigerant on a package unit, this is super easy. Disconnect the compressor from the circuit. Okay. Open up the indoor blower section, the panel, open up the condenser section. Manually turn on the condenser fan motor and the indoor blower motor. Let them run for about 25 to 30 minutes, just circulating the outside air across the evaporator and across the condenser. Then what you do, put your service gauges on the unit and look at the saturated refrigerant temperature. It should be the outdoor ambient temperature because you're letting the outdoor ambient circulate across the blower section and the evaporator and the condenser section with no compressor running. The refrigerant in the system should be the same temperature as the outdoor ambient temperature. Okay, so therefore you can look at a temperature pressure chart, find your saturated temperature, and it should equal the outdoor ambient temperature. If it doesn't, plus or minus, 2-3 degrees, then you have a problem there, okay? Oftentimes you'll find mixed refrigerants when you have R22. People will put 407C, MO99, different things on top, and you'll be able to see that in your saturated temperatures, okay? Once you get into more split systems and different things like that, it does get to be a little bit difficult to try to figure out mixed refrigerants. It's just one of those things. It takes some time looking at what your pressure should be, you know, and things like that. So, all right. Does my pricing change based off of clients, as in big guys and small guys? Not really. I mean, I have one particular restaurant chain that I don't charge the same hourly rate as everybody else. They get a couple bucks lower just because they're business friends of ours and they've been really good customers for a long time. But most everybody gets the exact same price, the exact same markup all the way across the board. There has been instances where we've had like family friends that have had restaurants, and we'll usually give them a little bit of a deal. But other than that, they pretty much are the same price all the way across the board. So, oh, how do I size receivers when I make my own condensing unit? Well, I've never made my own condensing unit, Shortcutter, but if I was to size a receiver, you basically need to figure out the amount. I mean, if you really wanted to know technically how to do it, what you need to do is figure out the amount of refrigerant that your system's going to hold. So you got to figure that your condenser is going to be have liquid refrigerant coming out the bottom. Basically, you're going to have liquid refrigerant going all the way down the liquid line. You can calculate the capacity of those lines. I don't think that's something you really want to do. Typically, you can kind of make a ballpark guess depending on the size of the equipment and how long the line set is. You know, it's not really going to hurt to go with too big of a receiver. I should be careful about saying that. You don't want to put a receiver that holds 75 pounds of gas on a system that only, needs a 10-pound receiver. But I mean, I would suggest looking at the Copeland installation manual. I have it right back here. There's actually a link to the video or to that book inside the show notes of this live stream. And it's the Copeland refrigeration manual, and it tells you how to size everything. It'll help you a lot with that. Let's see what else. Justin P., you had a woman turn on a breaker while you were replacing an outdoor light in an attic. It almost made you fall off the ladder when you shock it. Yeah, good thing. Yeah, honestly, I've been there too, bud, where you almost want to punch someone. I've never been electrocuted, though, so how do I size? Hopefully I get in here. All right, let's see what else. Let's see, you added R22 to a 502 unit. It still worked. No, that's interesting, bud. Be very careful about that. Have I ever put in the wrong tonnage of TXV? Yes, I have, to where you have to basically, I shouldn't say I've put in, but I've came across the wrong size expansion valve where it was restricting the system or it was flooding out the system. Yes, I have. You definitely want to lean on the manufacturer. Heatcraft publishes a lot of data. I happen to have a Heatcraft unit manual right here. You can download these from heatcraftrpd.com, their online thing. It tells you how to size the valves for their units. You typically want to lean on the manufacturers of the units that created that to size expansion valves because they're the ones that know what size nozzle is built into their system. So for instance, like Russell, I believe, Russell Coil, they have a nozzle built into their distributor, so you don't add it, okay? On Heatcraft units, they'll typically have a nozzle that comes with the expansion valve and you select the right size nozzle. But again, still lean on the manufacturer to size those valves. So, right on. Okay, how long does it take to get an HVAC license? Well, in Southern California, you don't have to have a license to be an HVAC technician. You only have to have a contractor's license to own a business. The only license you need to be an HVAC technician in California is a EPA Section 608 certification to be able to handle refrigerants. Other than that, you just need some schooling or someone that's willing to hire you and teach you. Other states are different, so you got to read your local rules and stuff. Oh, sorry, bud. Yeah, my bad. All right. What's the model number on the Fastco motor for evaporators on a walk-in cooler? Hey, Chad, send me an email and I'll give you 9721, maybe? I can't remember right now off the top of my head. All right, gentlemen. I am going to wrap this up. I really appreciate you guys taking the time to come into this stream. Do me a favor and send me some feedback in the comments. Let me know if there's anything that you'd like me to talk about in the next stream or something. I will go ahead and cue up the outro music right now, and we will catch you guys on the next one. Again, I really appreciate it, and we will see you guys next time.